Hey viewers, welcome back to the channel. So today's video, this is the first part of the deep dive into all of the pool equipment and what I chose and why. And so I figured I'd break this into two parts. First, this one is going to be about the equipment itself, no fancy automation, and then the next video we'll talk all about the automation system. So let's start from the beginning to the end, right? So we talked about the skimmers previously. This pool has two skimmers. They are the Aqua Genie skimmers. We talked about how they're a little different in that they have the return jets built in. So two of those, right? Two pipes. So all those are fed with 2-inch pipes in the ground that go right to the skimmers. Dedicated lines for everything. We're not mixing anything in the ground, so we have a dedicated line for every single thing to the pool. I think that's important. It allows you to isolate things and just do anything that you need to do and not worry about stuff mixing together underground that maybe you don't know about. Here you can see I expanded it up to 2.5 inches. Why I did this is quite simply because I forget what I'm doing sometimes, and really I should just taken those to 2-inch, just like you see on those other manifolds there. So there is no reason why this is 2.5 inch other than I got things twisted in my head. That's 2.5 inch. Each has its own shutoff valve, right? They're both open, maxed out, no blending or anything. Going to 2.5 inch T, and then here we go into a check valve. So this is a flapper check valve, and this may or may not be needed depending upon who you ask. The reason for this is to try to not starve the pump of water. So if basically preventing water from backflowing this way and sucking the pump dry. I've seen kind of probably even amount of comments saying, hey, this is good, or hey, it's not needed. So I figured it couldn't hurt, so that's why I put it in. And then we've got the pump. Before we get to the pump, we should know that your pump will most likely specify you have a minimum distance of straight pipe that has to be in front of the pump for the suction. You need to respect that, otherwise your pump won't work efficiently. I forget what mine was. It scales up and it's different for, I think, depending upon what your inlet pipe is, like 1.5 inch, 2.5 inch, etc. So read the manual and do what the manual says. The nice engineer who made that manual for you is trying to help you. So, hey, look, there's Smokey coming to say hi. On to the pump. This is a Hayward variable speed pump. I don't know if I can see the model number for you. Oh, it's down here maybe. All right. So the model number? I'd say a model number maybe. So 2.7 horsepower pump, variable speed. This is like one of the bigger ones that they have. And the key thing here is variable speed. That way you can run this thing low and slow, rather than having a pump that ramps on and off where you have to, time it, run it so many throughout the day. What I do is this thing is running 24/7, and it's currently running about 34%. And you want it low enough, just enough to trip the flow sensor on the salt cell so that you're making chlorine, and just enough turnover in the pool to where your pool stays clear, right? So in my case, at about this speed, I'm turning the pool over a couple times a day, running 24/7. So far that's been perfectly fine to keep the water clear. If it looks like it isn't, then we can increase it. At about 34%, this thing is using about 150 watts. So it is sipping electricity, and that is delightful. This thing running out maximum will use about 2.4 kilowatts. So this thing will really pull the power if you need it. And that is certainly required when you're running the water features, which we'll talk about in a minute. So variable speed pump, what you can see here is this is the control box for the pump. Notice it is dark because we're using the automation system. If you didn't have the automation system, you would use this control panel to do all the magic with it. And this control panel can be rotated, 90 degrees, 360 degrees in 90-degree increments, so that you can arrange it however you arrange your pump, which is kind of nice. This is your wiring cover, basically high voltage, low voltage. So if you are using the automation system like I am, all your low voltage control wires go here. All your high voltage 240 volt wires go here. This pump is 240 volts. I think you could get by running it on a 15 amp circuit. I went with a 20 because that's just the wire I had on hand. But we can actually look at the motor plate here and see what does it, if it actually tells us. If it's that the WEF number. I wasn't planning on doing this on the fly. So here it says 230 volts, 10 amps. So yeah, you could run this on a 15 amp, 240 volt circuit if you wanted. I chose to do a 20 with beefier wire. It doesn't matter, it'll work. Other thing to note about this pump has a bonding lug. That bonding lug is, let's see if I can get it right back there. You want to bond it to your bonding grid. We talked about the bonding grid in the previous video, but let's go over that real quick just so I don't have to remind you. You had the bonding wire, right? That goes all the way around the pool and bonds all the metal and all of the rails and everything. That bonding wire is coming up right here from the pool and hitting all the things that need to be bonded to. So whenever I say, you know, reference bonding it to the bonding grid, that's what I mean. We're tying it all back into that line. So that's the pump. We come out of the pump, again, up to 2.5 inch, because that is what the fitting sizes are. So I figured go big or go home. Because the bigger the pipe, the less restriction that this thing has to flow. And that is exactly what you want. Nice and easy movement of water, nice and gentle. So we are going up and over into the filter. That right there is a temperature sensor. We'll talk about that in the automation video. Into the filter. The filter is the Hayward C5030. I think this is the biggest cartridge filter they have for residential. This is slightly upsized from what we needed. If I could have gotten I think the 4030, it would have worked just fine. But they didn't have it, and so I got the big one. And so I figured, hey, it's less stress on the system, filters will last longer, etc., etc. It certainly doesn't hurt. You'll notice as we're running low and slow there, right, that our pressures are 0. There's no pressure. It is nice and easy. So that is our filter, and it's basically, yeah, come in here, go out there, pretty easy, right? You'll notice on some of this, because I got comments on some of the other videos, you know, you don't see any purple primer here. I used clear PVC primer and clear PVC glue to make up these joints to try to keep it clean. You'll notice I ran out and I had problems. I had to get the thing done because I actually spilled about a half a bottle of that clear primer and couldn't get any more. So it made me sad. One day I'll clean that up, but just so you know, clear PVC primer does exist. So if you want to make it nice and neat, you can do that. While we're on the topic of that, you are joining dissimilar plastics. Make sure you use the right glue. Example, this is PVC, use PVC glue. These here are PVC. Actually, some of these are PVC, some of these are ABS. And so what I did was, if I wasn't gluing PVC where I knew it was PVC, right, I used a universal glue. So that and a universal primer. Again, you can get a clear primer. And what that does is that will basically bond PVC, ABS, CPVC, whatever. So make sure that you're using the correct glue for the correct material. In my case, all of the valves, right? All the other little doodads, the pump, all the unions, all that, I use that universal glue, and I haven't had a leak. It's been great, worked great. So that is my recommendation, just to pay attention to that. So here's the filter. As I said, the filter has a pressure gauge. Basically what you do on this is you kind of rotate these around. Once you get the pump going 100% and you kind of see what your expected flow through pressure is, you set that to the green dial here, and then you can kind of monitor it, and whenever you start hitting the red, then you know, hey, I've got some restrictions, maybe I should clean my filters. I think that's generally how it is, but read the manual so you know. You know, at the top we got a little pressure relief valve to relieve pressure in the filter. An option that I decided to do on this filter is, see down there, it just came with a drain plug, and so when you need to change out your filters, you'll need to drain it, obviously. So rather than just having a drain plug and having the water go everywhere, I went ahead and routed, a valve, and that routes, you can see, following it down this way. And I did put a little slope in that pipe so that we kind of slope down into this T, which goes underground, and that hits our buried corrugated line that we talked about. We showed on previous videos. So that will dump it all the way out to the creek and keep it nice and neat. So that's the filter. Coming out of the filter, we come out here and we'll show our pipe strap first. This is how we did the pipe strapping to float it. That is just a set of some strut with a clamp that I bolted to the concrete with tap cons, and then a pretty cover just cause. And these are just normal pipe clamps, so 2.5-inch pipe clamps for 2.5-inch pipe, and it works pretty well. So that is what I decided to do to strap the pipe. And I need to do one here because this is still a little wobbly. I need to put another one there, but we'll get there. Next in the chain, this is our sacrificial anode. So we have a saltwater pool with steel walls. While corrosion should not be that big of an issue because they are super zinc coated steel walls, and the liner should prevent leaks, etc., 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 this is still a good idea. So what this is basically, this allows a place for corrosion to happen. So instead of corroding the steel walls of the pool or anything else, it will corrode this thing first, which is called a sacrificial anode, for just that reason. This thing will destroy itself and is easily replaceable, right? So that you can replace it and not have to deal with corrosion in your pool. So at least that's the theory. You'll also note this comes with a bonding lug. Therefore, you should bond it to your pool structure. Moving along, I put in a 3-way valve here. This is just for draining the pool. So if I want to drain the pool down, at least, as much as I can get out of the skimmers for whatever reason, I've got the option. So I put a 3-way valve in here. So whenever I throw this to block it off, I can route all the water being pumped out of the pool here instead of here. And that runs to that same drain that we talked about. So in hindsight, that will do a little bit, right? But once you get down kind of below the skimmers where the skimmers can't suck anymore, it becomes kind of useless. If you put main drains in your pool, which I did not, but this would be a benefit of having them, then you could basically close off your skimmers, just pull from the main drain, and you could drain the thing all the way down to the deep end, which is a benefit if you ever need to drain your pool for liner replacement or whatever, but that happens so infrequently. Throw a sump pump in and you're fine anyway. So it's a convenience. It's pretty cheap to do, right? You got like a $60 valve and some fittings, so it's not all that terrible to plumb up if you want to do it. So do it if you want. So then we come in and we have a lot of piping here that is really unnecessary, but there's a method to the madness. So we come all the way over here, right? And we have this loop. Now you may ask, why do we have this loop? Well, at this point, if you did not blow your budget on your pool like I did, you may want to add a heater. And if you did, then maybe you drop a heater right there. So this is what I did. I basically spec'd out the heater that I thought I was going to use, got the measurements, made myself a template, and set these pipes, both the distance, left to right, and the height to where the inlets and outlets of that heater are going to be. That way, whenever I do get the heater down the line, all I have to do is chop those fittings, right, and glue on the unions and drop the heater in, and it should be that simple. I'm sure it will be. It probably will be, but try to make it easier on ourselves. That way, future Chris doesn't hate me. Here we got another temp sensor. The only reason it's here is because it came in the box with the automation system, and I figured, hey, if I'm going to have another temp sensor to monitor, maybe right out of the heater, so I could see the delta between the pool water and the water coming out of the heater, and see how close we are until we get to temperature or something like that. At least that's the theory. I don't know if that'll actually work in practice, but why not? Next, we have another check valve here. And this is to protect the heater whenever I add it. It also has, so I don't need it right now, but it does have the side benefit of, this is an analog flow meter. It shows gallons per minute of flow, which I like. So here we're saying we're running about, if I can read that, about what, 38 gallons per minute flowing. So nice and steady. now we go in here and we're getting into the salt cell now. So this is our flow switch. This is what basically it's a trigger for the salt cell. So you have to have water flow in order for the salt cell to operate. So this is kind of a kill switch. And so this that's what that does. And you can see right now we're reducing down to 2" because all the salt cell fittings and everything are 2". So I would have loved to keep it 2.5, but there's no way to do it. In hindsight, they give you, when you buy the salt cell, they give you this T with this fitting and everything. And this is just a normal PVC T. You know, it's like a 2" by whatever this is, like 3/4. So I could have kept this 2.5" all the way to this point until I adapt here. So if I could have got 2.5" by 3/4 if I wanted to keep that pipe diameter. I doubt it matters that much, but if you wanted to, you could. Now we're into the salt cell, unions, and then this is the salt cell, and this is what generates the chlorine, right? Using electrolysis, it takes the salt inside the pool, right? Sodium chloride, breaks it apart, and you get free chlorine out of it, and that's what sanitizes your pool. And that process just kind of cycles forever, basically, to where the salt gets broken up, and I'm sure it gets like reconstituted and broken up, etc., etc. And so the salt stays in the pool, you know, quote, for the lifetime. You have to add it probably periodically here and there, but it's not like it goes bad or anything. The salt cell, you can mount it horizontally or vertically. I chose to do vertically mainly because of space. And if you do it vertically, you get the benefit of making sure that salt cell always stays submerged in water. So there's a specific orientation, like it has to go this way. You can't flip it upside down. That way that cell stays submerged in water, and you don't run the risk of, you know, overheating it or damaging the salt cell if it's running, but you get an air gap or something like that. So coming out of there again, union, up and over and down here to another T. So this tees off to our returns. So we'll talk about the main path first. So this takes us back to all of our returns. So we've got our 2 skimmer returns, right, which would be here and here. We've got our quote normal return right in the sidewall of the pool, right over by the shallow end and the steps. Then we've got our slide here, all right, and then we have our future waterfall pipe, right, that pipe that we stubbed up by the slide there. That's where that terminates. So, and all those are open right now. The water features are turned off, but everything else is open and flowing, right? I haven't balanced any of the returns or anything. It's everybody in, everybody out. This T goes to the deck jets. So we have a valve, automated valve that we'll talk about, but a valve tees off to 2", and we come down, snaky plumbing to try to get all this to match up and fit. And then we go into a 2" balancing loop here. So this is a full loop, as you can see here, okay? Full loop. That then we break off into 3 dedicated 3/4" lines with their own valves, and those 4 3/4" lines go to the 4 deck jets in the deck there. Right? And I'll show all this in operation whenever I do the automation, because it's easy to turn on and off and kind of show you how it works. That's pretty much the plumbing. A couple hindsights on everything. The deck jets work great. They don't shoot as far into the pool as I want. What that means is, even with the pump going at maximum, if I have everything on, right, they can only shoot as far as they can shoot. So the way I would remedy that is I would have a dedicated pump for the deck jets. So in hindsight, I mean, not that I would, with the budget, I wouldn't have been able to actually probably afford it and do it, but I probably would have plumbed this just a little bit differently to where I can integrate a second pump in the future. And that's what I'll probably do as a booster pump. So it would be after this main pump, at which point I would probably have to tap off here, basically go to a pump, right, and then come back into the balancing loop, you know, here, and push those. And that would give me enough oomph to really shoot those jets out. And then if they go too far, I can adjust these valves to dial them back however I want. And then you get the best of both worlds, where you can keep your big pump going low and slow, right, to cycle the pool water, but then ramp up the small pump whenever you want to do the water features. As it stands right now, anytime the kids are in the pool and they want to to do stuff, right? You want to slide and everything, and you turn all that stuff on. The pump ramps up to 100%, so it's burning a lot of electricity. Not a huge deal, especially if you're only swimming for a couple hours or whatever, but you know, if you're looking for maximum energy efficiency, honestly, that'd be the way to do it. Get a dedicated pump, I think, for each water feature, and only turn that little pump on, you know, small pump, the smallest pump you can get probably, and only turn that pump on whenever the water feature is active. So, but all in all, it turned out really well. The system's been pretty rock solid, and I am super happy with it. So I hope you guys enjoyed the video. I hope it was informative. Oh, I forgot one more thing. The lights. We'll talk about that. So the lighting, how that works basically is we've got the 4 lights in the pool, right? Not that you can see them, but they're dotted around the pool. And if you recall, we've got those 4 conduits that come up and feed each one of the lights. Those go into this junction box here, which is bonded, okay? And this junction box, they just wire nut, right? We just connected them all into one line that then feeds into the transformer here. So the right side's the low voltage that takes all the lights in. The other side is the high voltage, right? Which is just a dedicated 120 volt circuit. 120 volt. I did 20 amp because again, that's what the wire and breakers I had. You could do a 15 probably and get by with it because I think this is only a 300 watt, maybe a 500 watt transformer. So it's not using that much power. And then that, you know, comes out the high voltage side to the panel. It's worth noting because I made this mistake. This circuit does not need to be GFCI protected. And that's something I didn't mention on the other one. This pump, this circuit must be GFCI protected. That is not an option. Do not cheap out, buy the expensive breaker, cry a little bit and get over it. You have to GFCI protect this thing for the pump. For the transformer, not so much. And the reason why is because it's a transformer. There is no electrical connection between the lighting wires and, right, the lighting wires over here and the actual power wires coming in here, right? It's all magnetics, right? It's how transformers work. So there's no physical connection between the primary coils and the secondary coils. Therefore, a GFCI protection on this side would do nothing. If you have a dead short on the low voltage side and you try to electrocute someone with the 24, or not even that, 14 volts of AC going to that pool, the breaker will do nothing. And that is exactly why I chose to do low voltage wire lighting versus high voltage, right? Just because I don't want to mess with it. And it's even though you can make 120 volt lights safe, they've been in in-ground pools for a while, low voltage is an option, so why not, right? It's a lot easier to deal with. Okay, that's it. That's all the components. I still owe you guys a lighting video. I'll do that at night and get that to you to show off how the lights work and pros and cons and all that kind of stuff. So I hope you enjoyed the tutorial. I know it's a little longer one, but I want to make sure you got all the information. This, you know, like most of my videos, right? This is a one take on my iPhone. It's just me jabbering and talking. So maybe I missed something. I'm not sure. If you have any questions or anything was unclear, please let me know, and I will respond to you in the comments and try to help as best I can. So as always, thank you all for watching. If you like the content like this and any other content I've done, please like, share, subscribe. It helps out the channel tremendously. I greatly appreciate it. Helps us get more views and grow the channel. And then additionally, if you want to support the channel, you can do all your shopping via our Amazon affiliate link in the show notes. You do your Amazon shopping normally through that link. It costs you no extra money, and the channel gets a kickback of anything you buy, and we greatly appreciate it. So thank you again for watching, and we'll see you in the next video.